Okay, we seem to be recording, so let's go ahead and get started. I like this question of the day from the last time about languages. I was quite impressed that such a high percentage of you speak 2 languages or even more. So that was quite interesting to me to see the result for that question of the day. I remember that on the main page, I have a link where you can take the personality test, where I've made a new version of the big data file. So now we're up to about 175 people from the class. It'd be nice to get even more. We're still have a high percentage of introverts. Right now it's at 73%. You can see if you take a look at the resources that are on the homework tab if you're interested. Reminder that Monday is a holiday, so there won't be a lecture that I'm recording on that day. So today I'm going to finish up my discussion of Chapter 8, and then Wednesday of next week, when we come back from the break, I'm going to be talking about your final homework assignment, Assignment 8. So we're kind of approaching the home stretch. Okay, so let me switch over to JGrasp. I wanted to review some of what we talked about last time, and I wanted to emphasize certain ideas, maybe give you a slightly different explanation for some of these things that we're talking about. There's a fellow named Arthur Reel who wrote a book about object-oriented design heuristics that I read many years ago when I was trying to understand object-oriented programming. And I felt that I learned more from his book than any other book that I had read. I mean, maybe it was just because, I found his book early. But I thought he had some very interesting ideas. And he had a suggestion. It's funny now because he made this suggestion as something that's a good thing to do when you've got an auditorium full of people. Well, I got to auditorium, I just don't have all the people, but we can pretend. I can kind of still talk about the idea of something that he said is a good thought experiment to do with people, which is, he said, you got this big audience of people in an auditorium. You should ask people, so raise your hand if you think that let me set this up better. He said, think about a radio. So I know radios aren't quite so popular these days, but you can still go to a place like Best Buy and buy a radio. If you stay in hotels, you get a little clock radio. So you're going to encounter radios at various places. So he says, think about that, a radio. What if you encountered a radio in the world? And so the first question he says to ask is, raise your hand if you think that you'd be able to use a radio if I put one in front of you. You all raised your hands, or almost everybody raised their hands, because lots of people have confidence that they'd be able to figure out how to use a radio. The second question he says to ask is, how many of you could build a radio from kind of low-level component parts that you would buy at a place like Radio Shack, assuming that any Radio Shacks still exist? And, I normally get like 1, 2, maybe 3 people in a room this size who raise their hand and say that they could build a radio. So he says this is a really important thing to understand, is 2 different views of an object like a radio. There's kind of the view from the outside, someone who would know how to figure out the dials and switches and so forth, how to use a radio. And so one of the views is the external or outside view of an object. And we refer to that as the client view. So I mentioned that term in Wednesday's lecture. That what we're writing here, where we have a main method, is that this is client code. So we construct a point, we call various methods like a translate method. So we do things with the point. So we construct them, we manipulate them. It's like having a bunch of radios on the desk in front of you, or having a bunch of point objects on the desktop in front of you. We're a client of that class, of that object. So that's kind of one view. And so knowing how to use a radio is a lot easier than knowing how to build a radio. So there's this kind of second view, which you could think of as the internal or the inside view of an object, which we would talk about as the implementation view of an object. So that's what we're seeing over here in the point class itself. And I know this may be a little confusing. Maybe, I mean, that I'm switching back and forth. And so this kind of, you have to keep track of, are we in the program that has main in it, or are we in the code that's just for the class? So I've been kind of switching back and forth between these two files. And when you go to do homework 8, you're going to do a similar thing, where you're going to be switching back and forth between a lot of different files. So this is more complicated than what we've done before. It's not all going to be in one class. It's going to be in multiple classes. So this thing that I've called Fry here, short for Friday, is my client code. That's kind of the outside view that's using it. And so you want to make it easy for a client to use an object. So the client doesn't have to know how to translate coordinates. It just needs to know that it can ask a point to translate its coordinates. That other view is kind of the inside view, and that's what we were talking about when we were over here, and we were saying we were inside of the point class. So that's kind of this other view. There's a term, a phrase that I mentioned last time that is a nice little summary of a lot of the main ideas from object-oriented programming, that an object encapsulates state and exposes behavior. And before we're done with today's lecture, I'm going to have explained all these different words and what they mean. We saw a little bit of what they mean last time, but I want to kind of use them a little bit to review. And by the way, let me point out, I'm doing things in a slightly different order than the textbook. The textbook makes a third version of the point class and a fourth version. I'm going to combine a bunch of stuff. I have a long list of little details to go through. So we're going to combine a lot of little things, and I'll just have a third version of the point class that I'll be posting at the end of today that has kind of where we end up with all of this. So, if you think about Arthur Reel's example of a radio, I usually ask the class, what are different states that a radio can be in? And people are usually pretty good at giving me things about a radio. It can be on or it can be off. You can change the station. You can change the volume. You can set it to be on AM or FM. So there's a lot of different things that kind of go into the state of a radio. And what are the behaviors of a radio? Well, behaviors are things that tend to change the state. There's an on-off switch that turns it on or turns it off. There's a knob that lets you set the volume. So change the volume, change the station, switch it from AM to FM, turn it on, turn it off. Those tend to be the behaviors, things that change the state of an object. So what did we do last time? We basically said that a point, we're giving it a blueprint for what a point would be like. We're describing a point to Java, and we began by mentioning that it has these fields called X and Y. That was what I said was the most important thing to understand about a class, about an object, is that it's got state information inside of it. It's got some fields. So this state information we stored in fields, which is kind of like variables, but it has a different status than variables. I mentioned the fact that local variables go away when methods finish executing, so they have a very short lifespan. But fields stay around as long as the object stays around, so they could conceivably exist for a very long time. It's a little unfortunate that the syntax is so similar to the local variable syntax. And then the behavior is methods, that we define methods that you call in order to get the behavior that you're interested in. So we spent a good amount of time talking about a translate method that changed the value of X and changed the value of Y. The textbook and the slides talk about terminology that's often used for this. This is a mutator. A mutator is something that changes the state. And I included also another method here that would be known as an accessor, something that accesses the state, or you could think of it as a read-only type operation. That mutator, accessor terminology, it's not so important. So don't worry, it was good to mention it for completeness, but you don't have to worry about memorizing accessors versus mutators or understanding which one is which. But we didn't have time to write this one, but I threw it in at the end last time. I mentioned that there's an extra method in here that computes the distance from the origin. So it looks up the value of x and y as a way to use a standard formula, the square root of x squared plus y squared, to compute its distance from the origin. I did want to pause for at least a minute to remind you of something that I mentioned last time that's in the slides and it's in the chapter, which is that there's a picture of an object that I think is a good one to have in mind. It's kind of an idea of thinking about what this class is describing. What is this blueprint saying? And what I would say is that the blueprint says that when you go to construct a point object, you set up 4 different things. You set up a field called x and a field called y. So there's a place to store an int x, a place to store an int y. There's some state information that's inside the object. There's also something known as translate. And I keep making the analogy that this is like a steering wheel inside of a car or something, that it's a bit of behavior, it's a method, and that every time we make a point object, we make a specific translate method that translates that point's x and y coordinates. Just like when we make different cars. This one has a steering wheel that turns it. This one has a steering wheel that turns it. This one has a steering wheel that turns it. So this point has a translate method that updates its x and y. This point has a translate method that updates its x and y. This point object has a translate method that updates its x and y. And the fourth thing is the distance from origin method. So each of these points is also constructed with a specialized version of distance from origin that computes the distance of that specific point. So this kind of all led to us talking about the idea of we have been doing static methods, and that kind of what we're moving into is what are known as instance methods. And so that kind of leads you to, students wonder what's the difference between static and instance. It's subtle. I think that a lot of students, even when they're leaving the 143 course, are hazy about this distinction between static and instance. But I will mention an idea, for those of you who want to try to understand, I remind people in my 143 course of this idea. Static is something where there's one for the entire class. So there's only one version of something for an entire class. And the math class is a good example of this, because all of the things in the math class are static. We don't make new math objects and ask this math object to give me a sign or ask that math object to give me a sign, because there aren't 2 different sign functions. So I don't need individual versions of sine, cosine, max, min, and so forth. And I don't need, this is true of constants too. I don't need, a bunch of different math objects, all of which have their own version of the pi constant. There's only one. I only need one constant to keep track of pi, one sign method, and so forth. And so those are all static in the math class, because one is enough. I keep talking about cars, and it's very obvious with a car that each car you build needs its own steering wheel. So you need to have one for this object, this instance. You need a different steering wheel for this car, this instance, a different steering wheel for this car, this instance. I mean, you could imagine a static steering wheel. It's a very strange idea, but kind of what if at the dealership there was one static steering wheel for all the Honda Accords in the world? I mean, that would be really very bad. I mean, because, like if they turn the steering wheel to the left, all the Honda Accords in the world turn to the left at the same time, because there's one steering wheel for all of those different ones. So you don't want a static steering wheel. You want each car to have its own steering wheel. And similarly, we want every point to have its own xy, its own independent xy, so that each different point can keep track of its own coordinates, and they're going to be different. That's why we don't want static for those. And for the methods, because the methods act on those fields. Maybe I'll mention the practical version of it that a lot of you care about. The practical version of it is that any constants you would declare, we would still make static the way we have all quarter long, but everything else you're going to be doing in your homework 8, you won't use the word static. So you'll just stop using the word static for homework 8, other than constants. So that's kind of the practical way of thinking of what we're going to do. Okay, well, that was a whole lot of discussion about terminology and concepts and review. So let's kind of, what we had was something that made a couple of point objects, translated their coordinates, printed out their distance to origin, so that we didn't actually do that in the lecture, but you know, I showed it to you at the end. I want us to kind of continue by writing some code that would print out the 2 points. So, you know, the usual thing to do is system.out.println P1 equals P1, system.out.println P2 equals P2. So that's what we've been doing all quarter long. Some of you might suspect that it may not work so well, but let's kind of compile and run and see what happens. What's that? Point, and then an @ sign, and then some weird characters here that sort of look like a number. I mentioned to you that this is the kind of this crappy version of a method that's trying to turn this into a string. It gives the name of the class, point, followed by an @ sign, followed by a sequence of base 16 digits, what's known as a hexadecimal number. And the Java documentation kind of implies that this might be the memory location of this object, but they don't quite say that. So anyway, it's funny. Java doesn't want you to quite know the memory location, but they imply that that's what it is. Anyway, this isn't what we want. We want to be able to see the XY coordinates. We want to see what's inside this point object if we go to print it. Well, what I'm going to do is I'm going to do kind of a bad version of this, and then a medium version, and then we'll get to the good version. So the bad version would be, okay, I'm the client, I'm on the outside, and I say to myself, well, I can't just do this because it's not going to work right. So what I'll do is I'll just do the work myself as the client. So I'll do an open parenthesis, print out the x coordinate, have a comma, print out the y coordinate, and have a close paren. So I'll just kind of do the work myself of having a nicely formatted bit of output, you know, of the x and the y coordinate. So I could do that, and if I recompile the client code and run it again, now I'm getting kind of that a nicer output. I'm seeing that the x, y coordinate is 2 and 3. So that would be good. That would be kind of a nice version of this, and I could do the same thing here and so forth. The problem is with it is what I mentioned last time, that you want to be kind to your clients. You don't want to make clients do a lot of work. You know, kind of printing out what's in a point is something that might be something that you want to do a lot of times. So why should all the clients out there have to keep doing all of this work? You know, I made a joke last time. I quoted my friend Owen Astrachan from Duke, who has this joke, you know, as a variation of JFK's famous speech, ask not what you can do for an object as a client, ask what an object can do for itself. So we don't want to have this here. We want this to be in the class itself. So the idea would be to set up some kind of a method here, public. I'm not sure what's going to be the details of the method. We'll have to see. And what I wanted to do is something that's kind of like what we're doing here in the main. Now, you could imagine that this is going to be a method that you could call print. You know, that would be, you know, we've got to fill in some parameters potentially as well. You could have a print method. You could tell a point to print itself. We could certainly do that. I think that by now you should realize, you know, we don't always send stuff to system.out, you know, so printing it to system.out is not always the thing you want to do. What if you want to send it to an external file? You know, then a print command that sends to system.out wouldn't work right. Well, and you also know sometimes we use strings like this and we put them in a graphics program, you know, so what if we wanted them to be graphical in the output? So we don't normally do a print method. What we normally do is think about converting this into some string equivalent. So I'm going to have a method called convert that returns a string. So I'm going to have it compute a string that kind of shows what's inside of this point object. So that means that a lot of this stuff is going to go away because we're not printing anymore. I'm going to return a string that has an open paren, x, comma, y, right paren. So I'm going to put together a string instead, and then in the outer program, in the client program, I'll figure out whether I want to be printing it or whether I want to be putting it in a graphical output or whatever it is I want it to do. So the question of what are the parameters and what about the P1 and so forth. Now, remember that we've gone back to we're in the point class here. So we're back inside of the point. And I said a minute ago there were 4 things that every point had, an x and a y and a translate and a distance from origin. Now there's going to be 5 things that every point has, that a point is also going to have a convert method. And points automatically, because we're inside of the point, they automatically know that they're associated with the x and the y for this point object. I said last time that it's like being inside a car. If someone says turn the wheel, you know what they mean, because there's the one wheel inside of a car. That's different from the client view where you've got to say P1 or P2. I've got a bunch of different points because I'm on the outside. Here I'm on the inside of a single point. And so I don't need to say this P1 dot. I just use a simple name like X. I don't say P1 dot, I just say Y. Because this is something that's inside of the point class, so it can see the X and the Y. I've mentioned before, this is a little bit about that idea of global variables that we mentioned before. It is kind of like a global variable. It's something that we can refer to throughout the class. And so this is going to make a method known as convert that gives me back a string that represents the data stored in this point object. Let me make sure it compiles, and then let me come over here. And so instead of doing all of this, what I'm going to do is I'm going to say P1 equals P1.convert. I made a method out of it. That's good. So this is getting us to kind of the medium version. So the other one was bad in that we were making the client do all the work. Now it's nice. We made a method. We added it to the behavior of the point class. So the point object, provides this method. Much easier to call a method, than to have to try to do all the work ourselves. So it's good. The point class does it for us instead of us having to do it. And when we run this version, we can take a look at the output, and we're still getting our formatted 2, 3, our kind of nice output that shows the 2 and the 3 in there. All right, so I wanted to mention the idea of having a method that would convert the state information inside the point into a string. We've done that with this convert method. But then I usually ask, haven't we seen this before when we were working with arrays? People are like, yeah, we saw this before. And wasn't there a different name that we used for it? And people say, yeah, it was called toString. So it's okay to call it convert, in a sense. But the Java convention, when you make a conversion method like this, is to call it toString. That's the standard name that's used in Java, is to call it toString. So I'm going to kind of just change its name over here. We'll recompile. And then over here, instead of calling convert, I'll call toString. And so now I'm assuming that what we're going to see when we run it is the same thing, right? Where I'm going to see the formatted thing here because it's calling toString, and this one will be in the screwy format. So let's go ahead and compile and run, and you see the nicely formatted one on the screwy format one. How come that doesn't have the kind of the screwy output that it had before? How come this is nicely formatted when we're not calling toString? That's a mystery. So let me tell you the answer to the mystery. So it turns out that you can call toString yourself, and what we would refer to that as is an explicit call on toString. You specifically said to call the toString method. But there are many places in Java where there's what we would call an implicit call on toString, and this is one of them. When Java goes to concatenate P2, to this string, it calls the method toString. So it calls that method that's known as toString. And so here what it's calling is a built-in version of toString, a crappy version of toString that gives us not what we're looking for. But one of the important things to understand is that every object in Java, every class in Java has a toString method one way or another. If it doesn't define its own, it gets this crappy version of toString. Now what we're doing here is that we changed the definition of toString. We gave it a new definition and said that it's got a different name. It's got a different behavior than it had before, and that then causes it to change what's happening even in this one where we aren't specifically calling the toString method. It's important to know that when you're doing this, that you have to spell things correctly, just right. So like, what if you made it toString with a lowercase s? And let me go ahead and compile, and I'll come over here and run this version of it. And we're back to getting the crappy toString here and the crappy toString here because we didn't properly redefine the toString method. This is something that almost every programmer has to learn at some point in time when they're dealing with a language like Java. I remember early on I spent an hour trying to figure out why a method of mine with this name was not being called. And it took forever because I was like, why is it not being called? Why is it not being called? And I didn't realize that instead of defining a method known as window closing, I had a widow closing. And there was no such method that anybody was calling, and that's why my method never got called, because I misspelled things. So you're going to have to be careful when you go to define things that you get toString just right, just the right capitalization and so forth. So let's put it back the way it was. Oops, I didn't mean to execute that. I meant to execute the client code, so we'll run it one more time. And now we're back to seeing it in the nice format. Okay, so that was the toString. I mean, as I said, I got kind of a long list here of little details to talk about today. What I want to talk about next is kind of what's going on with these lines of code here. And some of you might have thought about this the very beginning, when I was first showing these lines of code. So I guess what I would say is think about something like the following. What if you ordered a car from a car dealership, and they delivered to you a silver car, and the next day you took that car into an auto shop, and told them to paint it blue. You can do that. You could be given a silver car and then repaint it to be a blue car. But I mean, one of the questions would be, why didn't you just order a blue car to begin with? I mean, if that's what you wanted was a blue car, why didn't you just tell the factory to give you a blue car in the first place? I mean, well, maybe they don't have the color available. Lots of reasons, why. Maybe they only had silver cars. That was true of me when I bought my first car. But in any event, we've seen things like this before. Why would you say, give me a point that is going to turn the x and the y to a 0, 0, and then I turn back around and reset them? Why don't I just tell it? Well, give me a new point that's got a 3 and a 5 in it. So instead of kind of doing this, why don't I order the blue car to begin with? Why don't I say, give me, hey, point factory, Java, when you're constructing this point, why don't you give me one that's got 3, 5 in it already? So I want to do that next. And so in order to do that, we have to understand something that is known as constructors. So constructors are like methods, but somewhat different. So they have a lot of similarities, but also some important differences. So, one of the differences about a constructor is that it can't be called the way a method is. You can call a method, any time. A constructor is only used in conjunction with a call on new. So when you say that to create a new object, it's calling up a constructor. It also has a different kind of header. So what have we been doing in our headers? We've been saying public static, but we're not going to say the static anymore. So we've normally had a return type here and a name of a method, and then some parameters. So we've normally put two things here, like our translate method, a void method called translate. Two different things, void, translate, so the return type and the name. Well, what would we do for a constructor? It does return something. The whole point of a constructor is that you're saying, hey, make me a new point object, and it returns a reference to the point object that it constructed. So in a way, what you'd say is that the return type is going to be point, so that this would be kind of point. And what is its name? Well, we're kind of saying, call up new point. That's kind of like its name, point there with the parens. So you could imagine that Java would have had it look like this, point, but that's not what Java decided to do. Java decided that you'd have only one thing. So instead of having both a return type and a name, you kind of just combine it into one thing, and that one thing has to match the name of the class. So when you see only one thing here and it matches the name of the class, that's a constructor. That's how Java recognizes that something is supposed to be a constructor. We'll have some code here to have inside of the constructor. If you did happen to say put something like public void point, suppose that you wrote it that way, that is not a constructor. So it may look like a constructor, but it's not, because Java sees the two things. It sees a return type and a name. This is a method called point with a capital P that has a void return type. So for constructors, we're going to be careful to just kind of do this. And so what would we do inside of it? Well, let's take a look. You can see that you're passing some kind of an initial value for x and an initial value for y. So we could describe that as int initial x and int initial y. We're passed parameters. And what do we do with that? Well, we want to use these things to give a value to the fields. So we set x to be initial x, and we set y to be initial y. That's what we want our constructor to do. Now, initial x and initial y are parameters, so they're like local variables. They have a very short lifespan. They only exist while this constructor is executing. But notice that they're being used to set the fields x and y. So they're setting those fields that have more permanence to them, the state information of the object. Well, one of the things you might wonder is, why didn't we have to do this before? So let me mention a rule that Java has, which is if you don't define any constructors, Java will define one for you. And the constructor it'll define is a zero argument constructor, the kind of the empty parentheses constructor. So what we were doing here, where we had kind of the empty parens, that's a zero argument constructor, Java will give that to you if you don't have your own constructor. It'll make a zero argument constructor for you. Here we're defining our own two argument constructor, and I can do the similar thing here with a 12 and a 4, and then I won't need these. I'll just comment them out to remember that that's what we used to have to do. But now we can just kind of directly set those things up. Oh, and what did I do? I had some kind of, I had an extra set of curly braces. I think I was trying to plan ahead and have closed curly braces, but that was a failure. We can ask it to recompile everything. And let's just, nothing should have changed, but let's just run it and see that we're still getting the same output that we got before, which is good. Okay, so that's a constructor. I mean, as I said, there's a lot of syntax, a lot of little rules to learn about how Java allows you to define classes. So we're just kind of learning more and more of these, adding more and more detail. That's why we do the different stages, so that you can see kind of the simpler versions and then the later versions. Well, I wanted to throw in one more thing, which is, what if I had a point P3, which is where I did the old style thing, where I did the zero argument constructor, the empty parentheses, and then maybe here I'll say system.out.println P3 is equal to P3. By the way, I'm going to go ahead and get rid of this, that call on toString. People would consider that to be kind of amateurish, to have the call on toString, because we all know that that's, just kind of concatenating is going to do that for you. Well, let me compile this code, and I get an error message. Constructor point in class point cannot be applied to the given types. So let me tell you what's going on here. So let me remind you what this little rule said, that if you don't define any constructors, Java will define one for you, a zero argument constructor. So before we had no constructors at all, so Java made a zero argument constructor for us. Now we want a zero argument constructor, but we've defined our own. So Java figures that if you define even one constructor, then you must know what you're doing. And if you meant to have a zero argument constructor, you would have included a zero argument constructor. So I'm about to do that. I'm going to have us add a zero argument constructor. What we're doing when we do this is something that's known as overloading. So there's going to be two different versions of the constructor. Java allows you to have two or more versions of constructors and of methods. So you can have a bunch of different methods that have the same name as long as they have different, what are known as signatures. So what's the signature of a method or a constructor? The signature is the name plus the number and type of parameters. So what it's saying over here is it's saying, look, you seem to be trying to call a point constructor with empty parentheses. And what it says is, when I look over here in the class, what I find is a point constructor that takes an int and an int. So its signature is that it's a point constructor. Its name is point, and it takes int, int. That's what it's saying right here. What I know about is int, int as a signature, as the parameter signature. And what you've given me here is zero arguments, no arguments. So it's kind of saying that's why I'm confused, because I don't have something that matches that signature. Well, so let's give it something that matches that signature. We'll have a public point constructor that has zero arguments, that takes no parameters. So two different versions of it, an overloaded constructor, one of which takes two ints and one of which has zero arguments. And we can just set x to be 0 and y to be 0. This is a funny case where we actually don't even need to do this, because Java will initialize x and y to be 0 for us. But I think it's not a bad idea to kind of be clear that that's what's going on, is that we're setting the x and the y to be 0 and 0. Well, let me try compiling this one and come back over here and recompile the client code, and then we'll try running it again to see if it's working now. And so all I changed there was that I set up the P3, which is set to the 0, 0. So it's using that zero argument constructor that we introduced. Okay, boy, lots of stuff. This next thing that I'm going to talk about is a very important idea in object-oriented programming, and it's one of the things that I think is the most difficult to really explain well to novices. You're just not going to see the benefits of it early on. I'll try to kind of point out the benefits when I can, but it's kind of hard to appreciate it early. But the idea is what we call encapsulation. So I want to talk about the idea of encapsulating state. And one of the ways I talk about this is that I ask people to think about the kind of devices like a radio or other kinds of electronic devices you might buy at a place like Best Buy. One of the things that I found is that when you buy these kind of, right, a device, a metal box or whatever, and you flip it upside down, often there's a little faceplate in there that has like 4 little screws in it, and it might even say, do not remove this faceplate, which I think is really, it's like tempting you to take out the screws and open up the plate. Why would they say not to open it up? Why would they even include it if it says not to open it? Well, it's there for a repair person, someone who's going to kind of, a technician, who's going to go in and need to rearrange something inside of this electronic device you bought. And I usually ask, is there anything that this also says on it? And people, a lot of times people have encountered this kind of a message. Not only does it say don't remove this, it says if you do remove it, your warranty will be voided. So often there's kind of that rule too, that that if you take off this faceplate, that your warranty is null and void. I mean, the thing is, they don't want you, let's suppose you take off the faceplate and you see some wires and you yank on the wires and break the wires, then you push it all back in and put the faceplate back on and take it back to Best Buy. It's broken, give me a new one. Well, they don't want to, guarantee that that's going to work. The warranty doesn't cover that. So that's why they say this is only for professionals. You shouldn't be doing this. Well, we've defined this class in a way that people can do what I was describing with taking the faceplate off. They can reach right in and do things. So, for example, they could do something like the following. They could say to P1's x-coordinate, I want you to be reset to be negative 308. They can just reach right in and set it to anything they want it to be. And that could be a dangerous thing to let somebody do that. For example, maybe you want to define this point class in a way that it guarantees that x and y are never negative. That might be something that was desirable. And now someone can just reach right in and set it to a negative and screw up everything. So this might be something that we don't want to allow. The technical term that we use for that, for kind of reaching into the object and just directly manipulating it, we describe that as breaking encapsulation. We like to think about the object being encapsulated in like a metal or a plastic case so that you can't, you can turn the dials and push the buttons, but you can't reach in and muck around with the wires. So we kind of want to prevent this from happening. And there's a relatively simple way of doing this, which is to use a word that we haven't used all quarter long. We say private. So I'm going to say that X is private to this class and Y is private to this class. And that means that people aren't allowed to reach right in and muck around with the value of X and Y. So if I try compiling this version of it, it says, error, X has private access in point. Ha ha, you're not allowed to do that. You're not allowed to break encapsulation and reach right in and change the value of X. So this is a good thing, being able to declare things to be private. And I know a lot of you care more about the practical implication. So I'll tell you the practical thing to write down in triple circle in your notes, that every field that you will declare for your homework 8, and if you are doing an exam for what would be on the final exam, every field you're going to declare, you will declare to be private. So, that you need to encapsulate your objects. You need to have them declared to be private. And you would lose a style point if you didn't do that in homework 8. So even though that's the first time you're going to be working with classes, you're going to be expected to do this encapsulation of making the fields private. So be careful to do that to get full credit. This encapsulating idea, this kind of protecting the state information by having it in a capsule, kind of that prevents something from the outside. This is considered a very important design issue. There's a fellow named Joshua Bloch who's considered one of the most famous gurus of Java. He's written a lot of influential Java books about design. And he says that this encapsulation idea is the single most important design aspect when you're defining classes. So it's a very important idea. But the thing that can be confusing about this is that we're going to try to discover just the right level of encapsulation. So it's kind of like a pendulum swinging this way and that way. So before, the client had full access to X and Y. They could do anything they wanted, which was too much. But now we've swung the pendulum in the opposite direction, where they can't do anything with X and Y. And it turns out that's too little. So, I mean, like, this is something we don't want to let someone do, but why couldn't someone say, I want to know the sum of the X and the Y coordinates of P1. I want to know what those things add up to. But if you try to compile it, no, you're not allowed to do that. We've cut off your access. So what we tend to do is we tend to grant back some access kind of selectively. And it leads often to what are known as getters and setters. So I'm going to have a public int method called getX, where I return the value of X. And I'm going to have a public int method called getY, where I return the value of Y. This is because I do want to allow the person to look at the value of X and Y. I want the client to be able to see, what X and Y are, so that I give them that ability by having a method that does it. And if I recompile, now that's okay. Now it's allowing the client to do this. This is that idea, by the way, in that phrase, I talked about the idea of exposing behavior. You, as the designer of this class, choose what to expose to a client, what to make available to a client. And so it's a good idea to make a getX and a getY available to the client. In fact, I'm going to go a step further, and I'm going to do something that's in the built-in Java point class in AWT, which is I'm going to have a method called setLocation, where you can give a new value for X and Y. And inside of here, I would set the X to be X and the Y to be Y, so that the client could actually change the value of X and Y. Several things I got to say about this method, and some of you might already be thinking about, this doesn't work. It's actually, we're going to have to figure out why. But let me kind of first say, this seems like we've gone totally back to the other side now, that we've given them full access if they can call a set location, because now they could set it, say, to a negative number. Well, that's not really true, because they have to call our method, and we could say if the client is doing something bad, then we can respond. So it actually does give us some control that we wouldn't have otherwise, because they have to go through our method. And so we can decide kind of how that method behaves. But there's a more important thing that's going on with this method, the way that I wrote it. It's something that's known as the shadowing bug. So we define something called X and Y, which are the fields of this object. And I've said they're a little bit like global variables. They're visible throughout the class. But what I did in this one on purpose is I used the names X and Y again for parameters. So I've got two different definitions of an X and a Y. And the rule in Java is that the most local one is the one that it pays attention to. So when you say X in here and when you say Y in here, it means the parameters. And what it's doing here is it's setting the parameter X to be the value it already has, the parameter Y to be the value it already has. And what we really wanted to do was to set the field called X here, not the parameter. Well, there's a notation for doing that. You use that keyword this, which was for the implicit parameter. So I can say this.x and this.y as a way of referring to the fields rather than the local variable. This is something that, it's good to know that this kind of thing exists, but if you didn't deal with this until 143, that's no big deal. Some of this syntax is getting a little bit, more than what you need to know how to do. You can do the kind of thing that we did up here in the constructor, where you use a name like initial X or initial Y. You just use a different name, and then this problem doesn't come up. I wanted to mention just two more things. So one of them is that here I'm setting X and Y, but that's what setLocation does. So I can actually call setLocation, initial X and initial Y, within a class. You can call the methods of the class. So, here I'm in the constructor, and my constructor can call the setLocation method. One more thing that I'll mention is that there's a rule for constructors as well, which is that we don't tend to do this kind of thing. It's somewhat redundant to be setting X and Y. I mean, I could call setLocation here as well, but what we tend to do instead is to have one constructor call another constructor. This is, again, a syntax you're not going to need until 143, and even then not initially in 143. But there's a special notation using that keyword this, where you can have one constructor call another. This is described in the notes in the chapter. As I said, it's not a big deal, so you could kind of not worry about understanding all the details of that right now. But the final version will have this, where it's one constructor calling the other constructor. And let me just compile to make sure. I didn't give a type for my, where was my, setLocation. I misspelled initial Y. And it'll all be correct on the version I post to the calendar for today. Have a good Monday holiday, and I'll be back on Wednesday to tell you about homework 8.